So at this point, we're thinking maybe our application would be a little more exciting if we had the walls on the left and right hand side of the screen and maybe some ramps to help keep the ball in play. Now let's take a look at how they do it in the actual Peggle, or I guess my approximation of Peggle in Flash. And what I've done here is, you can't actually see them, but I've created some static bodies that make up the left-hand side, the right-hand side, as well as each of these little diagonal ramps. My ball interacts with them like they were static bodies. Clearly they're not moving in reaction to my ball hitting them. So we probably want to do something like that in our application. Now, keeping with our whole actor, hey, look at that, got a bonus. So keeping with our whole actor metaphor, I suppose one way to do it would be to make a left wall actor and a left ramp actor, or maybe several ramp actors, or maybe one giant left-hand side plus 3 ramps actor, or something like that. But I think we can probably go a little more general purpose than that. And so, taking it one step more general purpose, we can create something that I call the arbitrary static actor. What is that? Glad you asked. So basically, the way this actor is going to work, or the way this class is going to work, is we're going to pass in a list of coordinates, and we are basically going to turn that into a static shape. And so for example, if we wanted to create our little parallelogram, we could basically pass in our coordinates, maybe starting here and working clockwise. And very similar to how we set the vertices when creating a B2 body by hand, this arbitrary static actor class is going to set these vertices when creating the body, and then also when creating a sprite if we choose to draw one. So this works pretty well for our little parallelogram. This actually might have an issue with our arrow. Remember that shapes in our B2 world have to be convex, and this is clearly a concave shape right here in these little angles. So probably if we want to create this arrow, we'd have to break it up into 2 different shapes. So maybe for our arbitrary static actor class, instead of just passing one list of coordinates, we can pass a list of coordinates, and that will then turn it into one or more static shapes. So basically, I could create one list of coordinates that would define this rectangle, and a second list of coordinates that would define this triangle, all into the same actor class, and that would then create my little static arrow. I don't know if that was too confusing, but hopefully when we see it in practice, it will become a little less confusing. Although, I will admit, this is kind of a complicated class. My apologies. So let's quickly jump into creating our arbitrary static actor. I'm abbreviating arbitrary because I don't feel like spelling it out every time. Now, like with all of our other actors, we're going to pass to it a parent, and that's going to be a display object container, and a location, which will be a point. And then we're going to want to pass in basically an array of coordinates. So remember, this is going to be an array of arrays, each one of them defining its own convex shape. And that looks pretty good. Now, as it turns out, I happen to know that the functions used to create the body and the sprite from this array of coordinates gets a little complicated, so I've broken it out of the constructor and made it 2 different functions. So let's create the first one. We'll call it create body from coordinates, and we'll have passed to it our array of coordinates and our location. I can generate a function, and again our parameters are going to be our array of coordinates, and that's going to be an array, and our location, which is going to be a point, and is going to return a B2 body. Alright, here we go. So like before, we're going to define shapes, then we're going to define a body, and then we are going to create the body, and then create the shapes. Much like before, except shapes now is plural because I could be passing in more than one shape. So I am going to store these shapes in an array that I'm going to create empty. And now I'm going to go through my array of coordinates and get my list of points. So basically, right now what I have in my list of points, hopefully, is a list of points defining a convex shape. So I'm going to create my new shape def, which is going to be a P2 polygon definition. And its vertex count is going to be our list of points dot length. Now, if I wanted to program defensively, what I should probably do is double check that the length of my list of points is less than or equal to the number of vertices allowed in our polygon definitions, which by default is 8. I'm not doing that here in a vain attempt to keep my code from getting too large, but you should probably do that if you want to be coding defensively. So we're going to iterate through this list of points. Oops, sorry. Our next point is going to be our list of points dot I. Sorry, not dot I, but at I. And now we're going to set the appropriate spot in the vertices array of our new shape definition. So remember, our new shape definition already comes with a built-in list of vertices. This is going to be an array. We're going to want to change the vertice at point I, and I need to cast this whole thing as a B2 vec2 as my way of saying, okay, I know that this is going to be a B2 vec2 so that we can call this new function set. And what are we going to set it to? We're going to set it to this next point. It's going to be equal to next point x divided by our ratio. And our next point y. So basically at this point we have taken our first array of coordinates out of our array of arrays. We've looked through each point in that array and we have set the vertex of our new shape definition to equal the correct point. I hope this isn't too confusing, but I'm going to kind of forge ahead here. So let's just set a few things for our new shape definition. Because it's static, we'll set the density to 0. We can set the friction to something pretty small. And I'm going to set the restitution to 0.3, just because I happen to know these values work fairly well. And then we're going to take this shape definition and pass it to our all shape defs array. Fantastic. All right, I think that was sort of the hard work. Now we can go through the easier work. Defining a body is much like before. We'll create the body definition. We will set the position equal to the location that we have passed to the constructor, which we have then passed to this function, location.x divided by a ratio and location.y divided by our ratio. Now we can go ahead and create the body. By accessing our world, telling it to create a body, passing in our body definition. And now we're going to create the shapes. And we're going to do that by iterating through our all shape defs array and creating the shapes with our RB body. So in other words, I'm going to go look at for each So for each new shape definition that we have just stored above, we can now tell our body to create that shape. Once we've done this, even though it's not necessary, we can call our set mass from shapes, and then return the body we just created. All right, so I think this lesson's probably worth splitting up into two. I'm going to stop right here, but clearly the next thing to do would be to create the costume or the sprite that will make up the visual part of our static actor. So stay tuned.